Three blocks with masses m, 2m and 3m are connected by strings as shown in the figure. After an upward force F is applied on block M, the masses move upward at constant speed v. What is the net force on the block of mass 2m? Here g is acceleration due to gravity. In this problem, we have three blocks of masses m, 2m and 3m connected by strings, and the system is moving upward at a constant speed v under an applied force F on the top block, that is nothing but upon mass m. Since the system is moving at a constant speed, there is no net acceleration. Thus, the net force on each block must be zero. For the block of mass 2m, the only forces acting on it are the upward tension T in the string connecting it to the block of mass n, and its weight, which is 2 mg, acting downward. Since the net force on the block is zero due to no acceleration, the upward force T must exactly balance the downward weight of 2 mg. Therefore, the net force on the block of mass 2m is 0. Hence, the right answer is option D, 0. Options A, B and C are incorrect because they imply that the block of mass 2m would be experiencing a net force causing acceleration, which contradicts the constant speed condition. Only option D, 0, correctly reflects the equilibrium condition required by the problem.